Hey you guys. So this time I'm going to be looking at a obfuscated HTA script that contains a bunch of obfuscation and just encoded crap that eventually loads a PowerShell command and uses a combination of AES, encryption, and some other cool stuff to download and execute a payload. So I've already downloaded the sample. You can find a link in the description below. And I've created a copy named Lumma.hta, which is just the same thing as this here. So I'm going to go ahead and open that file inside of Notepad++, and we can see that it's a HTA file, which is just HTML with some JavaScript. Has some HTML stuff here, not really sure what it's doing, doesn't look very interesting. And if we go down to about the middle, we can see this JavaScript command here, which is the interesting part. So the way I'm going to deal with this is just get rid of all of the HTML. It doesn't really add any value. And I'm just going to focus on this. And if we look here, we can see it's actually VBS and not JavaScript, but it's essentially the same thing for this purpose. And since we just want to focus on that script, we don't really care about the HTML. I'm just going to remove all of the HTML tags and focus on this. And at the same time, I'm also going to change the text highlighting to Visual Basic, just to make that easier to read. And at this point, we can see there's 3 lines of code, but each of those lines is extremely long. So I'm going to turn on word wrap just to get a better view. And the first thing we can see is a bunch of variables being assigned to random numbers. That looks like some kind of obfuscation. Not really sure what it is just yet. And if we scroll down, we can see that each of those variables is converted to a character and kind of added all together into something. And what's interesting is they're not actually done in order. So we can see A116, A113, A32. So that just looks like a mess to try and decode manually. And if we scroll down a bit more, we can also see there's all these quotes which just mess up a script and probably don't do anything useful. Yeah, so the first thing I'm going to do is just remove those. I'm going to grab 3 of them at a time and just get rid of them with a simple search and replace. If we just give that a few seconds to run. Then hopefully we can get rid of them and have a better script to work with. And it's going very slow now. And here we go, we can see that they've all been removed. And they were used to hide this series of eval statements, which eventually executes RES. So what I'm going to do, because those evals don't really do anything except this RES, I'm going to get rid of those. And just replace it with that. And if we scroll up a little bit more, we can see there's just a lot of junk. And it's probably possible to decode this manually, but it just looks far too tedious to be worth it. So what I'm going to do instead of trying to decode it is I'm just going to delete the execute portion, and I'm going to write the output to a file. And writing output to a file in a VBS script is more lines of code than it should be, and I've just Googled how to save a file in VBS and I've copy and pasted from the first result on Google. So here we can see a couple of objects created, which are just a VBS way of creating a file, and that all looks okay. We're just writing the contents of res, which is what was being executed, to this lumma.out file on my desktop. So now that I've added that, I'm going to exit out of this. I'm going to rename the file to .vbs so we can run it. And I'm just going to let that execute. Now, hopefully, if I check my desktop, yeah, we can see the Lumma out.bin. Move that to my malware folder. And if we open that up, we can have a look at what's inside. And even though I named it .bin, it is actually a text bar. So that's good. No text highlighting, so I want to fix that. Apply Visual Basic. We can see possibly some obfuscation and decoding over here. Not really sure. And we can see what looks like actually a plain text PowerShell command here. So what I'm going to do is just copy that out into a new file. And I'll just analyze that separately to the rest. If anything goes wrong, I can always go back here and see if anything's happening. So now that we have that PowerShell script, we can see that it's one line of code, but that's only because there's no new lines and spacing in there. So I'm just going to go ahead and manually add a few new lines just so the code is easier to read. You could use a beautifier for this, but the script is so short that it's easier just to do on your own. Now, almost immediately, we can see this big blob of base64, which most likely is going to contain the next stage. And if we scan along for keywords, we can see references to AES, which is a form of encryption, from base64 string, which is being used to decode this big blob. And what else can we see? We can see another base64 string, which is assigned here. And if we just highlight that, we can see that is actually the AES key. We can see that key here. If we look along scanning for keywords, we can see that the AES mode is ECB. And that the initialization vector is this, which comes from this, which appears to just be the first 16 bytes of this blob up here. So with that in mind, we have the encoded text up here. We have the AES key here in base64 format. We know that the mode is ECB and that the IV is the first 16 bytes of this blob. And with that knowledge, we can go ahead, copy it out, jump into CyberChef, get rid of what we had before, and try to do that AES encoding. So first I'm going to decode the base64. And I'm going to go and grab the first 16 bytes so that I can use that as the IV. And I'm going to take a guess and say it's these null bytes here. So I'm going to copy those, remove the hex encoding, and then remove those first 16 bytes using drop bytes. If we go back to the script and we look here, we can see that yeah, the AES encryption actually starts at an offset of 16 and finishes at an offset of 16 from the end of this. So using that knowledge, go into AES decrypt and put the initialization vector in here, noting that it's in hex format. You take the AES key, paste it in here, keeping in mind that that's in base 64. The mode by default is in CBC, but we know from the script that the malware actually uses ECB. And I don't actually know what the difference is between those, but all I know is you need to change it if you see it inside of the script. So I'm going to change the input here to raw, because we're not passing in any hex formatted code. And I'm going to say that the output is raw. And let's see what we can get here. Nothing super useful. We remove the AES decryption just for a second. Sometimes there's some junk. We didn't. Yeah. We didn't remove the first 16 bytes. Now if we try and decrypt it again, still it doesn't look to be decrypting properly. I think we got the key and the IV right and the mode right. Potentially we've got something else wrong. What I like to do is, instead of looking at it like this, which just looks like junk, convert it into hex and see if anything stands out that is needing to be removed. And nothing really stands out at first glance, so that's kind of annoying. Play around with the mode, change it to ECB, no padding. See if that makes any difference, which it doesn't look like it does. Okay, so we can see that there's a gzip stream here and references to decompress. So what's potentially happening is it's decrypted, but it's still in a compressed format. And if we convert that into hex, yeah, we can see the 1F8B, which is the gzip header. So we can go ahead and apply gunzip. And still it looks like something's not working. convert it into hex again. See if there's anything that just looks wrong. Usually whatever's wrong will be at the start or the end of the file. This looks right. This here looks a little bit funny, so what I might do is actually remove that. So what I'm going to do is I'm going to take this, all of this output, I'm going to paste it in here, remove all of the decryption that we've already done, and just get rid of these null bytes and see if that helps. Invalid file signature because it's in hex. Let's see if this makes any difference. And here we go. We have what looks like another PowerShell script. That's cool. So I'm going to take that, open up a new file in Notepad++, apply PowerShell text highlighting, and see what we can get. And just like before, it's all on one line, so I'm going to add some new lines just to make it a bit easier to read. We can see references to TLS 1.2, also download data, file.exe, and what looks like some more encoded text. So I'll go through those one by one, but for now I want to focus on this giant blob of base 64. So I'm going to open up a new CyberChef tab. Let that load up. And I'll do a quick base 64 decode to see if I can get anything out of it. It doesn't look like there's any additional obfuscation. There's no references to AES or compression or anything like that. So let's just throw it in and see what we can get. And that looks pretty good with the exception of the null bytes. And go ahead and remove those with remove null bytes. And there we go, we get a decoded script. So I'm just going to paste that in. Paste that in here. And then I'm going to grab this other base 64 blob. And I'm going to do the same there. If we're lucky, we should get some more decoded text. And yeah, it looks like we have. So I'm going to grab that. And I'm going to add that into the new file as well. That didn't copy and paste for some reason. And here we go. Going to add PowerShell highlighting again, just to make it a bit easier to read. And what can we see? We can see a reference to user 32 and post message. Not really sure what that does, but we can come back to that later if it looks important. You can see the cmstp.inf, which I believe is a UAC bypass. You can see what looks like another PowerShell command here. You can see references to the registry key, the registry hive, and consent prompt behavior admin. So I'm pretty sure that's related to some kind of UAC bypass, and it's disabling the admin approval needed. If we look around, we can see that CMSTP is killed, and that a service is created and it's named Notepad, so that's a bit shady. We can see there's a bunch of stuff happening in here. It looks like it's writing this content to an inf file at this path. And what else is there? Honestly, nothing super interesting. It's getting a handle to some window. It's writing that inf file. But nothing that really looks like malware or nothing that looks super malicious. And there's no C2 and no encoded text anywhere, so that's strange. Overall, it looks like it's disabling UAC and potentially establishing some persistence in one of these, probably this path, and through something to do with the registry. Okay, so I'm going to assume that's persistence related. We've already decoded both of these blobs, and all we're left with is these weird decimals here. So what I'm going to do is I'm going to open up CyberChef again. I'm going to clear out everything we've got here. And I'm going to see how that is decoded. Looks like it's decoded at QNG, which is the same function referenced by both blobs of decimal numbers. But I can't actually see where it's being decoded. Oh, actually, maybe it's decoded by this NUL. Yeah, okay, so we see 5024. And for each value in the input, yeah, this UVX, which is 5024, is subtracted from the number. Yeah, we can see it's iterating through each array of numbers, one by one, and then subtracting 5024. So potentially what we can do is grab that. And again, use CyberChef. We could use Python, but CyberChef works well. And we can use some fancy recipes to try and mix this up. So let's try a fork, which will separate each of the values and allow us to act on them independently. So it's got a fork. We've separated on the commas and introduced a new line. Now we want to do a subtract. We could use sub, but sub only works for numbers that are less than 255. So our number's too big to do that. We've got our subtract. Now all we need to do is take this 5024 and add it to each line, because the subtract operator expects the numbers to be on the same line. So let's go ahead and use a find and replaced to make that a bit better. So what I'm going to do is use a capture group that's going to grab the content from each line And then I'm going to replace it with the same value followed by 5024. See if that works. Didn't work. Because regex has added a second number. If we turn off global match, looks like that's fixed that up. Now we can apply subtract again and tell it that there's a space between numbers. Perfect. Now if we do a from decimal, yeah, that looks a bit more interesting. Net.webClient. Go ahead and change the merge delimiter to an empty value. Yeah, we get the decoded string net.webClient. Not super useful, but we're on the right track. We go ahead and grab this second blob here. Do the same thing again. Run our recipe. There we go. We get a URL and IP address where a file is being downloaded from. And what I'm going to assume is this is where the next stage is hosted. That file is downloaded and saved as file.exe. And then it's going to be saved and persisted via the script that we determined before. So I'm not super familiar with the registry and how INF files work, so I'm not going to go too far into that. But if we jump back to CyberChef, we have our C2. URL C2. We know where to go looking for our next stage. So, awesome.